In here, we got a cool result here from James Webb Telescope regarding the early universe, and this here really borrows heavily from Hubble Space Telescope, and the key theme here is the shapes of the galaxies that are in the early universe. And let's look at the specific region that we're looking at here. The region, according to this article, is within the 600 million years to around 6 billion with a B years ago. And scanning through this particular image as shown here, there are a couple of highlights here with regards to some of the common thread that is showing up right here. The thread here is going to be specifically looking at the shape, and the shapes here are interestingly designed here that is more dominant at that particular time frame but less dominant nearby within us. And in this particular video, we'll also talk about how our Milky Way's galaxy in terms of its shape may be related in some way to the early universe galaxies shapes that we have actually seen in this particular result produced by James Webb Telescope. And so this is really a huge accomplishment in terms of how much Hubble Space Telescope is able to produce these results that are coming pretty much decades ago. 1995, that was when the first depth image of the early universe was produced, and building on the image and how we're able to compare that image to this particular new image from James Webb Telescope, seeing new things that are showing up here, increasing the resolution to see clearly the galaxies and pointing them out and seeing the extreme impact of those results from James Webb Telescope borrowing from Hubble Space Telescope really shows the long-range research that we are actually pushing for in science, which is really awesome to see. And so, looking at these shapes specifically now, we got some dominant images that we have right here that are samples according to the Cosmic Evolution Early Relay Science Survey. And this here reveals that, yes, that the galaxies in the early universe are often flat and elongated like a stuffed board and pool noodles, and are rarely round like a volleyball or frisbee. And this here, according to those dominant shapes of the early universe galaxies, is roughly around 50 to around 80% of the galaxies that are showing these flat features in 2 dimensions, according to this particular author here. And Hubble Space Telescope crew here reveals, according to the statement, that the galaxies that look like a pool noodles or a stuffed boards seem to be very common in the early universe, which is surprising since they are not common at all nearby within our own galaxy here. And so these here are images from the near infrared according to James Webb Telescope results here. And in here, looking at the details about the image that was first shown, looking at the early universe, looking at James Webb Telescope, there were 2 galaxies that were samples here of showing how one is really showing that interesting circular look that is more spherical, and the other one is more elongated. And so according to the description of this image here, it says here that this here James Webb Telescope found an array of odd shapes when the universe was only around that particular age ago, and the insert at the top left show a galaxy that looks more like a sphere and is at least common in James Webb results. Now, and this here is the least common in James Webb's results. Now, the ones that are more are the ones that shows or appears to have edge on disk but may be better classified as elongated galaxies. And though the elongated shaped galaxies are way more dominant on this particular image here, and this is pretty cool according to the Webb survey. Now, coming to the description of other things to keep in mind, specifically looking at our Milky Way, and the question here is, what category are we going to put our Milky Way based on what we have at the early universe stage? And so it says here that if we're able to turn back the clock of time to around 1 billion of years, the best guess, according to this analyst here, is that our Milky Way is more like a stuffed board looking, according to this author here. And it says that this hypothesis is based partly on new evidence from the Webb theorists have that is a would back the clock to estimate the Milky Way's mass billions of years ago, which correlates with that shape at that time. So it's pretty cool to see the age and the mass of our Milky Way at that particular billions of years ago and comparing it with the data of this image of the early universe, and maybe from the mass results of this early image here, it shows that the elongated size matches what we're hoping that our own galaxy had that particular time frame ago. So that's pretty nice way to approach this. There might be some other things in here, like in terms of the coloration and how much in terms of the gravitational lensing might impact the mass of some of the galaxies that are reviewed right here. But overall here, pretty astonishing to see this analyst here take this hypothesis on our galaxy relative to this other early universe galaxy here. Now, the other 3D classifications of distant galaxies here, according to this image, it shows that the top elongated appearance are the ones, the top three, are the oldest ones that are much more dominant at the early universe. However, the disk-like appearance and alongside the spherical appearance, which are the bottom three, are more recent and nearby to us. So the ones at the top, nearby to us, are really less, but to the early universe, they are way more dominant, but the ones below, they are much more closer to us, which means that they are more dominant within our own time frame, and they are less dominant at the early universe time frame. So these here are some of the examples that were shown here according to the analyst here. And so this here, now looking at Hubble Space Telescope, it shows here that for decades Hubble has wowed us with images of some of the earliest universe galaxies, beginning with its first depth field in 1995 and continued with a similarly survey known as the Cosmic Assembly Near Infrared Deep Extragalactic Legacy Survey. And the Deep Sky Survey like this led to far greater statistics, leading astronomers to create robust 3D models of distant galaxies over all of the cosmic time. Now today, Webb has helped to enhance these efforts, adding a bounty of distant galaxies beyond the Hubble's reach and revealing the early universe in far greater detail than previously possible. Now, Webb's image of the early universe have acted like an ocean swell that is delivering a new wave of evidence. Now, Hubble has long shown an excess of elongated galaxies, explained this co-author here, a faculty research scientist at the Institute of Astrophysics on the Canary Islands. But researchers still wondered, would additional detail show up better with sensitivity to infrared light? And Webb confirmed that Hubble's didn't miss any additional features in the galaxies they both observed. Plus, in addition, Hubble showed us many more distant galaxies with similar shapes, all in a great detail. Now, this here is actually incredible to show also the gap in our knowledge and how we are able to fill those gaps here, according to researchers here, in terms of not only looking at the small sample size to a much more larger sample size, which is pretty much coming from James Webb's telescope, not only showing the refinement in the properties, but also precision in the locations of the distant galaxies. And so they will also need to spend ample time wrinkling and updating their model to better reflect the precise geometry of these distant galaxies. Now, these are early results definitely to keep in mind according to this analyst. So we are hoping that this early result will be a great foundation for further more research to come and results to come based on the geometry of these galaxies, and gives us a better diverse look of different shapes of the galaxies coming from the early universe to where we are right now in terms of nearby galaxies. So I hope you found this really informative in terms of the shape of early galaxies, which are much more elongated galaxies compared to the disk appearance galaxies and spherical appearance of the galaxies. And let's know your thoughts about all this in the comment section down below. You'll find this really informative. There are more in the description in terms of the article to find them, and I hope to see you all on the next one. All the same, stay smart as always and believe in yourselves.